brief video introducing the use of Venn diagrams to test categorical arguments for validity. Now, what we're working towards is using Venn diagrams to test categorical syllogisms for validity. And that means, of course, an argument where we have two premises and a total of three terms. So we would need three circles. I just want to illustrate that you can use Venn diagrams to test some immediate inferences for validity. You can use Venn diagrams to show whether the premises of an argument guarantee the conclusion when you're only using two circles and when you only have one premise. But it only works when there's only two terms, and I won't even say it works for all of the immediate inferences. But this might be a useful introduction to how the Venn diagramming method works in general, and I didn't want to completely leave this this topic uncovered because you really can use this method. We're going to learn several methods of testing categorical syllogisms for validity, and technically there's going to be some redundancy there. I've already given you a lot of information if you've watched earlier videos in these playlists, lots of information on immediate inferences and categorical logic. This will also be somewhat redundant, but who cares? Whatever, let's do it. I just want to illustrate now how you can use categorical syllogisms to test arguments for validity in categorical logic when you only have two terms, but that means it only works for immediate inferences. And the technique is very simple. We'll probably go over the general idea here in the next video for categorical syllogisms, but the general idea is very simple. Chart the premise, then look to see if the conclusion is already charted. If the conclusion is already charted, say the argument's valid, and you're done. If the conclusion is not already charted, don't chart it. Say the argument is invalid, and you're done. Because an argument is valid if the premises guarantee the conclusion. That means it's not possible for the premises to be true and the conclusion false at the same time, which means without adding any new information, if the argument is valid, the conclusion should already be there just by giving the premises. So for example, here's a simple Venn diagram, and this will be a conversion of an I-form proposition. If I say some puppies are pets, the Venn diagram is going to look like this. You have the puppy circle and you have the pet circle. And you overlap. And in the overlapping region, you place an X. To indicate that some puppies are pets. Now, if I make the argument, some puppies are pets, therefore some pets are puppies, is the conclusion already charted by the time I finish charting the premises? Yes, so the argument's valid. But now let's say I make the argument that all puppies are pets. Now this premise is not true, but whatever. It's not the point. Do the premises, if true, guarantee the conclusion? I say all puppies are pets, therefore all pets are puppies. Is that an argument where the premise guarantees the conclusion? Is that an argument where the charting of the premise already serves to chart the conclusion? Nope. But what if I say no pets are puppies? Again, the premise isn't true, but that's not the point. Does the premise guarantee the conclusion? If I say no pets are puppies, therefore no. If I say no puppies are pets, therefore no pets are puppies, does the charting of the premise serve to chart the conclusion, therefore demonstrating that it's not possible for the premise to be true and the conclusion false? Yes. No puppies are pets, therefore no pets are puppies. It works. The conclusion is already charted. And this would be the conversion of an E-form proposition. And you may remember you can convert an E-form proposition validly and an I-form proposition, and you can't convert an A. What about an O? If I said some puppies are not pets, well, there's a true premise for us. Some puppies are not pets. Therefore, some pets are not puppies. Nope, you cannot make that inference. The chart just looks like this. You have an X in the puppy-only region of the puppy circle. And it means some puppies are not pets, and it doesn't tell us anything about whether some pets are not puppies. We just don't know that from the premise. Okay, so that's how you can validly infer the conversion of an E statement from an E statement, or the conversion of an I statement from an I statement. Some pets are puppies, therefore some puppies are pets. No sharks are mammals, therefore no mammals are sharks, but you cannot do it for an A or an O. Some guinea pigs are not pets, therefore some pets are not guinea pigs. Not a valid inference. The conclusion's true, but it's not a valid inference. To illustrate that it's not a valid inference, we could once again give a counterexample. Notice how all these methods interconnect. Here's an argument with the same form. obviously true premise, obviously false conclusion. Some mammals are not hamsters, therefore some hamsters are not mammals. True premise, false conclusion, indicating that's a invalid. That would be an invalid inference because it's the conversion of an O. You can't do that validly. Conversion of an A, all guinea pigs are fuzzy friends, therefore all fuzzy friends are guinea pigs, not a good inference. Now, what else can you do? Let's just do one or two traditional square of opposition things or modern square of opposition since we're using the modern perspective here. Let's say I chart some puppies are pets, and I want to draw from that premise that it's false that no puppies are pets. Some puppies are pets, therefore it's false that no puppies are pets. Has the conclusion been charted? Here's my charting of some puppies are pets. Puppy circle, pet circle, X in the overlapping region. Is it false, therefore, that no puppies are pets? And is that demonstrated by this Venn diagram? Yes, it is. The falsity of the no puppies are pets claim is already demonstrated by the charting of the premise. Therefore, the inference, some puppies are pets, therefore it's false that no puppies are pets is valid. Now let's try going from I to A, an invalid inference. Some puppies are pets, therefore all puppies are pets. If I'm going to say all puppies are pets, I'm going to have to add some shading in the puppy-only region of these two circles. The premise, some puppies are pets, clearly does not demonstrate the conclusion, all puppies are pets. And therefore, it's not a valid inference. So that's the one on the square of opposition, whether modern or traditional, where you can't go from an I statement being true to the conclusion that its corresponding A statement is true. And that's it. I'm done. That was just a brief illustration of how it is possible to test arguments for validity using two circle Venn diagrams, as long as it's an immediate inference only dealing with two terms. And those were some examples. The conversions are the really easy ones. Stick with those if you don't need to do anything thorough for an exam or anything, and all you wanted is a few examples. We could have done more examples, but I'm already talking too much. I think we're done, and I'll go to Venn diagrams for categorical syllogisms probably in the next video. Let me state one more time, the procedure is simple. We might have to go into more precision in the next video, but the simple procedure is really very simple, and it's just chart the premises and then look to see if the conclusion's charted. If it is, the argument's valid, and you just have to say so. If it's not, don't chart the conclusion. The argument's invalid, say so.